Deep breath. Beginning of a chapter, and this is one of the, I would say, hairy sections. We'll do our best to describe this to you. It's all about pictures and rearranging stuff. Similar right triangles, nod your heads. Those are obvious to spot. Do you agree with me? Look for the right angle, but then checking for similarity. We just got to work on that. Now this comes back up. Do you remember in last chapter we used to? Dun, dun, dun. Remember geometric mean? No? Yes? Geometric mean, is it on our reference sheet? Dang it, it's not. So we've got to remember, geometric mean, whenever I think of that, I think numerator, denominator. One thing has to be the exact same in the numerator and the denominator. It'll come up, we'll review it. I'll show you. Okay, I'm getting confused looks. Remember, it looks something like this. You have your proportion. Geometric mean has to be in the numerator and denominator. And then whatever on the other side. Maybe like 4 and 9. Remember those? And then what is 4 times 9? 36. However, what's x times x?
X squared.
Yay! I love that you're saying x squared, x to the second power. So x is 6. Yeah, that's what we have to do today. You just have to be careful that the same thing, exact same thing, one spot numerator, one spot denominator. New question.
So would you say that geometric mean is 6, or would you say x equals 6?
You would say both. He said, would you say geometric mean is 6, or would you say x equals 6? Both. The geometric mean of 4 and 9 is 6. Thanks for asking. Here we go. Art seems so simple, but I want to make sure you understand. So in a right triangle, it's saying if you create the altitude goes from a vertex to the opposite side at a 90-degree angle. If you add that to a big right triangle, you have now created 3 right triangles. You see that in there? Okay, let me erase what I just drew. So that was the altitude. So now, since we've drawn in the altitude, we have 3 right triangles. We've got triangle ABC. Yeah, do you agree? But we also have triangle ACD. Do you agree that's a right triangle though? Yes? No? Yeah? And then we also have this one. Triangle BDC. How many we have? I get that. That makes sense. Now we've got 3 right triangles. Deep breath. These are all similar, but it is tricky, and I have a hard time visualizing this. My brain is like, overload. I don't know how to match these up. So I'm going to show you how I finally can talk myself through it. I have to talk it out loud, which is good because I'm teaching it. Because these are all what kind of statements right here? Okay, similarity statements absolutely matter what order they go in. Because a similarity statement should match, CB should be proportional to AB. CD should be proportional to AC. So we can't just, they're right triangles, put them in whatever order. Oh, they still have to match. And my brain has a hard time organizing this. So erase this part. Let's go down here. Guys, you have room in your margins. Just start drawing some pictures. So first, I'm going to highlight it. I have the advantage. Let me highlight triangle ABC again on the board in green. Here's ABC. Right there, yeah? The first thing that helps me organize is identify the right angle. In just triangle ABC, where's the right angle? Is it on A, B, or C? C. Okay, start with that. Because in the other triangle, that right angle should be in the same spot. Does that make sense to you? So let me highlight triangle CBD. Where is it? CBD. All right, D, right angle, right? Oh, good. Are they in the same spot? Okay, so right angle's obvious. We can put those in the right spot, but then I'm like, oh, and I get nervous for the next part. Because we have to make sure we put the C and the B in the right spot and the A and the B. This one I like. If you look at what I highlighted on the board, the red triangle and the green triangle, they both, without cutting it, use the exact same thing. Do you know what it is? It's an angle. They both use the exact same angle without cutting it into pieces. They use the entire thing. It is B. So right here, see, right there, without changing, they both use that corner. Do you see that? So that's saying B has to be in the same spot. Is it? We're good. And then these last ones, I'm just like, well, it's got to be A here. It's got to be C there. Nod your head so you can follow that. Maybe a little. Okay, let's do the next one then. So erase this. Oh, but we still use ABC. Oh, well, I'll start over. ABC. Here's triangle ABC. Highlight it. Red flag. right angle. Where's the right angle? Where is it? Alright, it's on C. So here's our right angle. Highlight, what are we talking about next? ACD? Check, check, check. Alright, where's the right angle on this one, guys? It has to be D, right? Because they are, do you know the vocab word? These two together form a... Not quite. I almost heard it. Look on, nice and loud. They're a linear pair, so this one has to be 90 degrees. So D. Oh, good. They're in the same spot. Okay, same as before. They both share something. What is the angle they both share? Sorry, shout it out. What is it? A. Yay! So A's got to be in the same spot. They both use A. So here's A. Here's A. And then C and B, they're just kind of like the leftovers that I put in place. They have to go in the middle. Does that make sense? Guys, are you doing okay with this? Okay, great. All right, are you okay if we move on and start practicing this? Just exposing you. This is the very first thing on our lesson. Try this one then. Dun, dun, dun. So we have to find the ramp, the height of the ramp. There's H. That's what we're looking for. Okay, let's first use this for our first part of the similarity statement. So triangle JKL. Where is JKL? This big one. Here's JKL. All right, guys, nice and loud. Where's the right angle? All right, let's draw an arrow to it. I don't know if that helps you, but it definitely helps me. So I've got to make sure that K, the right angle, is in the middle. Okay, let's compare it to triangle this one, KML. We just have to put it in order. Okay, K was the right angle. From the green triangle, what's the right angle? Okay, so let's make sure that's in the middle. Okay, do they share something? L. So L in the similar statement is last, so let's make sure it's last here. So it will go first. Oh, does that make sense? It's like breaking it down step by step. Okay, once you have your similarity statement, you can set up a proportion because these have to be in order. So they start with KM. Look, KM's first and last. So what's first and last from the other one? Yeah, so JQ would have to go here. All right, we've got KM from the picture, JK from the picture. Okay, I'm looking at this. We've got to use this one and this one somehow, right? We've got to put it in the right order. KM came from the green triangle, so let's use KL from the green triangle. Thank you. And then does that match KL? Oh good, it matches JL, which we can use from the picture. Nod your heads. You with me? Not going too fast. Okay, now just replace it from the picture. Instead of KM, they put H. Instead of JK, what can we put? Do you see it in the picture? Perfect. 4.7. Instead of KL, what's KL in the picture? 11. And then what's JL? Okay, this is like the warm-up. You guys rock these. Grab your calculators. Type it in. Don't worry about filling in the blanks. You are good at this. So we've got 4.7 times 11 divided by 11.7. Tell a neighbor first, in front of you, behind you, next to you. Whoa. Tyler? Okay. All right, this is what I heard, one exception. I heard about 4.4. Is that about right? Yeah? Okay. Don't forget to divide. Okay, let's go to the next example. All right, those directions are messy. Those directions say write similarity statements for the three triangles. My heart starts beating fast. Okay, we got this, we can do it together. And then find the given length. Okay, let's start with, are you okay if we just start with the Mondo one? Triangle ABC. Okay, that's got to be similar to, let's match it up with, let's go the one on the right. So let's do this one. Okay, first, I highly suggest, where's the right angle in ABC? C. right angle in, well, the green triangle? D. So D has to come last, because C was last on this one. All right, now we just need first and middle. They share something. Do you see what they share? They share B, right? So B has to be in the middle because it was there. So what are we missing? Fill in the blank. C. Not too bad. You okay? Now we have to do one more. Similar to, let's start over. I like comparing to the bigger triangle, so I hope you are okay with that. So I'm going to go back to triangle ABC. So I'm going to be using this one to compare it to. All right, let's see. It's got to be similar to this one. We just have to put it in the right order. All right, C was the right angle. So where's the right angle on this blue triangle? It's totally D. So D's got to be last again. All right, they share something. What is it? A. So A has to be first because it was first on this one. Fill in the blank. What's the middle one? Okay, vote. Thumbs up. Have these down. I get putting those in order. To be honest, I want to help you. Hey, not too bad. I'll take it. Okay, now we've got to solve for AD. So pick two of these that you want to use. So I would say there's one we have to use because it's the only one that has AD in it. Do you see it? What color is it? Blue. We have to use this one because that has AD in it. And then go back to your picture. Find one that either has DC or DB or maybe even both. That'd be fantastic. What color is it? Let's use these two to do our setup. You ready? Okay, we have to find AD. So I'm going to write over here. Let's put AD over something. So from this triangle, similarity statement, it's first and last. So what's first and last from this one? CD. All right. Equals. Okay, we used this one first, so we've got to go back and use this one again. Okay, look at your picture. We know CD, it's 24. We know DE, it's 18. Excuse me, DB, it's 18. Which one does this one contain? It's got CD in it, so let's use CD on top for the next part, and hopefully this falls into place. All right, so CD was middle and last. Hooray, middle, last, BD. There's like our outline to solve the problem. Okay, AD, do we know AD in the picture? No, so let's put X. CD from the picture, what is it? 24. Hey, CD again is a geometric mean. And then BD is, all right, go for it. Solve it. Good luck. I have no idea. 24 times 24, and then divide it by 18. Does it come out a whole number? It does? What is it? 32. So, okay. So I was way too excited. How did I know that 24 was a geometric mean? Just by looking at this? Just gotta see. Look, was it in the denominator and the numerator? Check. Okay, 32. I'm gonna leave this up here for the example. Try the second one on your own. Don't forget to do the similarity statement first. Try it, try it. Good luck. Take your time. Same. So triangle MNP. That's got to be similar to, somebody mind raising their hand? How did you match this one up? What one did you do next? No. All right, are you ready? How many of you, first question, how many of you did this little guy next? Great. How many did this big guy next? All right, little guy wins. We're going to start with little guy. So we've got this one compared to this little guy. All right, out of the big one, where's the right angle? The big orange one, I would say M, right? So M. But then I agree with, I don't know if you can hear Calvin, where's the right angle on the little one? All right, so that's got to be first, right? Because M was first. Okay, and then what do they share? N, so that's got to come next because it was next on that one. So N, what are we missing? M? Oh, do you have that? Do you have that set up? Okay, we've got one more to fill in though, right? Let's go back to the big one. And let's compare it to this, like middle guy, red one. All right, so triangle, similar to triangle Alright, M was the right angle, so where's the right angle on the red one? Q again, right? Alright, what do they both share? P. Alright, P's last, so P's gotta be last here. Fill in the blank, what are we missing? M. How many of you got that? Did you get that? Good work, I'm impressed. Okay, so let me erase this because I've gone all over it. Now we just have to decide which one to use. What are we looking for? NQ? Here's NQ, little guy. NQ, we're gonna have to use this one because that's the only one that has NQ in it. Alright, then looking at the picture, we've got MN, NP. I kind of feel like this one. Does that one work, guys? Yeah. Okay, so here we go. Let's start with NQ because that's what we're looking for. So NQ over NQ, that goes middle first, that has to be NM. It's going to be proportional to, they gave us NP. Alright, NP is middle and last. Does it go on top or bottom though, NP? Have to be bottom, right? First and last, oh, NM, hey. Another geometric mean, did you see that? Okay. NQ, from the picture, do we know NQ? Nope, let's go next. What's NM? 10. So that'd be on the top and the bottom. What's NP? How many of you figured that out? Did you get that set up? Okay, seriously, I'm impressed. That's very impressive. So 10 times 10, 100. 100 divided by 26? 3.8. Whew. How many of you got 3.8? Okay, I kind of like this because it leads you right into the next part of your notes. We just did all this. You just didn't realize you were doing it. So the next part of your notes looks like this. So all these theorems. Okay, fill in the blanks on the first one. So you can use geometric mean to find the altitude or to find missing pieces. So it's saying, if you have this piece, break it up with this piece, use this piece as your geometric mean. What? Did I lose you? Yep. So put this one in the denominator, and in the numerator, put these pieces in the opposite spots. It'll solve for it every single time. Depends. Ali asked, what are you trying to find? Usually you're trying to find CD, but for the most part you can solve for it. Okay, so that's the first one. This next one uses the same picture, so I'm going to erase what I just put up there. Talk about saying, okay, what if you know this whole thing, AB, and you know this little guy, DB. It's saying you can use this piece, CB, as a geometric mean. So put this one in both spots. Okay, why? Why does that work? You just did it. You literally did it. Look, let me highlight this. They're taking this green triangle and they're comparing it to this red triangle. Oh, that did not change color. This red triangle. Do you agree that that green triangle and the red triangle share that piece? They share the piece, so you can make a geometric mean. This last one is the same thing, only this other side. They both share the piece. You've got to make sure it's touching. Let's definitely practice that. I feel like the first one, the first example of these theorems, you all are going to get. The next one, you just got to remember one little trick, so let's practice it. Okay, come this one. Out of this, 8x4, do you know which one is the geometric mean? X's. So set it up. Put x in the denominator and the numerator. Okay, think about this. We can break up the 8 and the 4. Does it matter where they go? No, because you're just going to be timing them. So just choose. All right, 8 times 4, what is it? Okay, very first week of school, I had you estimate these. 32 is not a perfect square, but it's in between what two perfect squares? 25 and 36. So what's the square root of 25? What's the square root of 36? So our number has to be between 5 and 6. Does that make sense? Type it in. Figure it out. What is it exactly? We estimated it's between 5 and 6. All right, Garrison, round it for me. 5 point what? 5.7? Ish. 5.7, I'll take it. How many of you done that on your calculators? We good? Okay, this next one, letter B. I don't want this to trick you. Okay, letter B. Letter B, which one of those three values is the geometric mean? Y is. Okay, so Y in the bottom, Y in the top. Be careful with this next thing. Okay, I'm going to trace it. Are you ready? They're comparing this red triangle, work on my colors this time, to this green triangle. The geometric mean is Y because they both share it. Do you see that? Okay, be very careful. How do I want to lead you into this? One of these you don't use perfectly right here. Did that so confuse you? Okay, we definitely are going to use 2 because 2 is this piece of the leg, right? So use 2. But the other one, don't use. What are you thinking? Add them together. You've got to do the whole thing. What I see students do is they just put 6, but you can't break this one up. You got to do the whole thing. 6 plus 2, put it together, 8. That's what tricks some students. All right, we got this. What's 2 times 8? Oh, is this a perfect square?
Yeah, 4.
Cha-ching. Y equals 4. Whew. Let's keep practicing these ones. You ready? Number 3. I kind of like sigh of relief when I see number 3 type of question. Number 3. What's the geometric mean? All right, T. So T in the bottom, T in the top. Does it matter? Okay, something's gonna happen with this.
Isn't it 17?
Yes, Miss, thank you. Because think about this. 17 times 17, you'll get a number, right? But then when you square root it, it's asking what times itself equals that number. Well, yeah, 17, right? If you don't trust this, you do that later. That's the whole purpose of square root. It's saying what times itself equals that number. Well, 17 times itself equals that number. Number 4 is a tricky one. Be careful. What's the geometric mean on number 4? All right, so T and the numerator and the denominator. If it helps, highlight stuff. So we're comparing this big orange one to this little green one.
How do you know which ones you're comparing?
Because of the T. So I highlight the ones that are using the T. That's a great question. You asked, which ones do you know that you're comparing? The ones that are using T. All right, so definitely use the 9. But then what do you use?
15, yeah.
Add them together, 15. Good luck. I doubt that's a perfect square. I could be wrong. It's not. All right, 9 times 15, what is it? 135. Square root it, what is it? 11.6. Can I just do 11.6? Okay, try this last one on your own. Question, Taya?
I'm still confused on why you used the 9.
Great question. Right here. So we asked, how come the 9 instead of the 6? So I always highlight my geometric mean. So green triangle is using the T. Orange triangle is using the T. You okay with that? Now, when you're comparing, you always use the whole thing. So this whole piece is 9. This other one, it's using that whole orange piece. Put it all together, 6 and 9, 15. So it's everything at once. One entire piece of the triangle. Great questions.